There are few things more peaceful than a vast expanse of water. From the gentle sound of small waves lapping at your feet to the view of the far shore, there's almost something eternal about it. However, when the expanse of water is in an area where ever-increasing numbers of people need to get from one side to the other, the serene must give way to the practical. A way to get across and back again must be devised. This is just such an area where the James River ends its journey at Hampton Roads, separating Newport News and Suffolk. And this is the story of how the Virginia Department of Transportation made the wish for a crossing a reality.
The I-664 tunnel is part of a 20-mile interstate project extending from Hampton to Bowers Hill in Chesapeake, forming a final loop around Hampton Roads. The tunnel is composed of 15 sections, each as large as a football field, containing 2 bores, with each bore carrying a 2-lane highway. As each new tunnel section arrived, it was given its final preparation work, floated out to the construction site where it was lowered to the bottom and joined to a section already in place. We were able to sink 1 section a month until all 15 were in place. Such a task nearly defies description, and it required the utmost in precision and cooperation between our engineers and the contractors involved. As a matter of fact, to be able to repeat this process once a month in all weather conditions and have each segment placed within a precision tolerance of 1 inch is a fantastic accomplishment. We at VDOT are proud of the job that was done, and we invite you to view the operation beginning with the building of the tunnel segments and ending with a 4-lane, mile-long underwater highway.
The tunnel had its beginnings at Bethlehem Steel Shipyard in Sparrows Point, Maryland. There, workers cut and bent the heavy steel into the circular shells that form the underwater highway. Also at Sparrows Point, most of the tunnel's interior concrete was poured, and finally, the huge dam plates or bulkheads were welded in place on both ends of the tubes. Once the bulkheads were in place and the air was trapped inside, the entire tunnel section, a 28,000-ton mammoth mass of concrete and steel, would float. And the fact that it floated solved the problem of getting it to Newport News. The trip down the Chesapeake Bay took 60 hours and about 10,000 horsepower in the form of tugboats. Upon arrival in Newport News, the section was placed in the lay barge, a large double-hull catamaran-type vessel that supported it in the dock. The lay barge also guided the tunnel section to the construction site and lowered it into place, where it became yet another part of this submerged interstate highway. The operations center on the lay barge was full of baffling gauges, computers, levers, and controls. Bill Baker, resident engineer with Sverdrup Corporation, explained some of the controls and gauges and what they told the barge's operators.
And what you're looking at here is the control console for the longitudinal anchoring system for the barge. We have a 10 anchor system. This console controls 6 of those anchors. It moves the lay barge and the tube longitudinally up or down the trench. The 4 larger gauges that you see up in the top of the control room here are Martin Decker load gauges for the lowering blocks themselves. Each one of them gives you a readout on a particular block as far as the load that it's holding. The total of the 4 gives you the total load of that you're holding with the crane system that we have out there presently.
Let's go through real quickly, starting with the first one. We've got how much?
The first gauge we have up there is showing 350 kips. The second gauge is showing approximately a little over 450 kips. The third gauge, again, about 425 kips. And the last gauge is showing about 560 kips. So what you're doing is you add the total of these together, divided by 2,000, and you come up with your total load on the barge itself.
In tons?
In tons, in tons.
Since these tunnel sections were afloat when they reached their final destination, they needed extra weight to make them sink. Here's how that was done.
Okay, in the fabrication of the tunnel tube element in Baltimore, Maryland, at Bethlehem Steel Corporation, the first thing we have to do is fabricate for the tunnel element itself the shell plate, the interior ring plate of the concrete tunnel tube. Once this is done, then we can place the horizontal stiffeners and the vertical stiffeners on the tube itself in preparations for the form plate. Once the diaphragms are placed and all welded in place with watertight welds, then we can weld on the outer perimeter of the tube itself form plate steel in this fashion. This forms a concrete pocket that we can pour concrete in to achieve the weight we need and we desire to sink the tube.
Coordination is an absolute essential in an operation as complicated as sinking a tunnel. We asked the project engineer, Jerry Morrison, about the preparation and timing of having the site ready before the section is lowered into place.
Well, the dredging has to be the first thing that happens. You have to go in and dredge your trench out first. The next operation that you'll have is with your screed barge. He has to come in and place your bedding stone, the 2 foot of bedding stone that this tube rests on. That all has to be graded to a tolerance, a specified tolerance. We only have, by specification, 24 hours once that grading is completed to place this tube on the bottom. If it is not placed in that length of time, the tide movement moves this stone around so bad the tube has to be taken out and done again. So, yes, you have to work on a very tight schedule. You have to go out at the right times based on tides, and there's a lot of work underwater that's done before you do this.
Once all the final preparations were completed at dockside, tugboats pulled the lay barge with the tunnel section out to the channel where the process of lowering the section into place would begin. Incidentally, no matter how much time is spent in planning, something always unexpected happens. Watch the mooring line and watch the man holding the end of it. After the trip from the dock, operators on the lay barge maneuvered the tunnel section into the exact position for lowering it into place. Land surveys and laser beams kept the section in the proper position, while the survey towers constantly indicated the depth. Even with all the computers, lasers, and survey marks, the final critical step in the process was entrusted only to human hands. The job of this diver was to make sure the section was properly lined up with the section it would join. With only about an inch of tolerance, the diver's inspection was the final and critical step in assuring the proper alignment.
Start flying on and I'll get ready for the skim plate, all right? Okay.
Once all of this was done, he inspected the coupling devices, large couplers like the ones used on railroad cars that were attached to retractable arms. These arms were then set in motion, drawing the newly submerged section into a snug fit with the section that had been put down earlier. Since the bulkheads sealing the ends of the tunnel sections were 7.5 feet from the ends of the tubes, there was a 15-foot section between the bulkheads that was filled with water. As this water was pumped out, the resulting vacuum actually drew the sections together at their gasketed surfaces. The internal steel liner was then welded at the joint, and the connection was sealed with grout. The bulkheads were then cut out, and another 300 feet of underwater highway was in place. This operation was repeated until 15 of the tunnel sections were in place and joined, creating a mile-long highway well beneath the water's surface. In order to get building materials into the tunnel and waste materials out, the section at the water's edge had a huge hole for this very purpose. The workers themselves walked up and down 4 flights of steps between the surface and the first section of the tunnel. Incidentally, the huge concrete trucks and other heavy equipment needed in the tunnel were sealed inside the first tunnel segment before it was sunk, only to be driven out some 4 years later when the tunnel was complete. July 19th, 1989 was a date to remember in the tunnel's construction. On that day, members of the Commonwealth Transportation Board, the Commissioner, VDOT directors, members of the media, and other interested onlookers were gathered for a special ceremony. On that day, the last remaining interior bulkhead was burned out, and what had begun as 15 individual segments became a single set of mile-long, twin, continuous tubes. Many of those who attended this burn-through ceremony were later given an interesting souvenir, a paperweight made from the steel of that last interior bulkhead. Most of the interior concrete work was done when the sections were built. However, the 15-foot space where the sections are joined had to be done after the connections were made. A huge concrete form that perfectly fit the circular shape of the tube was put in place, and the concrete was pumped into the top of the mold. Once it was cured, the operation moved 300 feet to the next connection joint, and the process was repeated. After each tunnel section was put in place, the finishing process was begun. More than 2 million of these ceramic tiles were installed one at a time. These light-reflecting tiles greatly increased the visibility inside the tunnel. Wire, conduit, and cables were installed and connected to lights, television surveillance cameras, and other electronic sensing devices. After years of work beneath the surface, the changes in the underwater highway were apparent. Gleaming tiles replaced the rough-surfaced concrete, and modern lighting replaced temporary lights strung during the initial construction. While the work was going on below the water's surface, construction was taking place at either end of the tunnel on the ventilation buildings. These buildings are aptly named because they contain the huge fans that furnish the air supply to the underwater highway. During the construction of the vent buildings, the concrete pedestals that support the large fans were formed and ready for the arrival of the fans themselves. The day the first of these fans arrived was another milestone in the tunnel's construction. Incidentally, it took one tractor-trailer truck to carry just 3 components of one fan. As each fan was installed, it was calibrated and adjusted to such a perfect balance that the huge fan blade will coast for 12 to 15 minutes after its power is turned off. The ventilation in the tunnel is supplied by 24 of these fans, 12 in each vent building, that supply fresh air and exhaust in the tunnel. The fresh air comes into the tunnel through a huge air shaft directly under the road's surface. It then comes through vents at the curb level. From this point, the airflow is picked up by the exhaust system, channeling it into the air shaft above the roadway's ceiling. The fan system is rated to move 200,000 cubic feet of air per minute, which creates air movement of about 60 miles per hour in the air shafts above and below the road's surface. The airflow is of such force that it must be channeled through turning vanes as the fresh air enters, and through exhaust deflector vanes as it leaves the air shafts. An airflow of this velocity does not lend itself to making right-angle turns. These fans, powered by motors ranging from 60 to 100 horsepower, make up one of the most modern and sophisticated ventilation systems in use anywhere in the world. As you might imagine, all of the equipment necessary for the operation of this underwater facility takes power, and lots of it. Coming into the switchgear room with all of its transformers, circuit breakers, and gauges is a flow of 13,200 volts. All that power is dispersed from this room to the fans in the ventilating system, the air conditioning, the television surveillance system, and the lighting system. Also, In the event of a disruption of commercial power, an auxiliary generator starts immediately, so there is no power interruption. In a facility designed to handle such a large volume of traffic, a traffic management system is essential. In this control room, television cameras let operators scan traffic over a 6-mile stretch from 35th Street in Newport News to Route 17 in Suffolk. There's a total of 34 TV cameras, 20 of them inside the tunnel. Using the expanded vision of these electronic eyes, operators can spot disabled vehicles or accidents and dispatch assistance immediately. Through variable message signs, they can also advise motorists of alternate routes to use while the incident is being cleared. There is one other thing that will be remembered as one of the highlights in the development of this facility. On September the 19th, 1991, the Commonwealth Transportation Board officially gave the bridge tunnel complex a name with historical significance. The I-664 tunnel became the Monitor-Merrimac Memorial Bridge Tunnel, commemorating the Battle of the Ironclads that took place in 1862 in these same waters that are now spanned by this 4-mile interstate highway. The years of planning and construction had produced the $400 million final link in Interstate 664. Dedication Day came just 49 months after the first tunnel segment was lowered into place. Federal, state, and local officials, led by Governor L. Douglas Wilder, joined in the ceremony that welcomed the latest addition to Virginia's interstate highway system. With the throwing of a switch, a variable message sign signaled that the underwater connection was complete. While the Navy's Atlantic Fleet Band provided a musical salute for the occasion, the assembled guests boarded buses for an inaugural ride through this, the latest passage under the waters of Hampton Roads. For the motoring public, the long-awaited day had arrived. A line of traffic began to form as the barricades were being torn down. In fact, the announced opening day, April 30th, 1992, was only minutes old when this caravan of motorized first-nighters began to roll. Some had waited in line for 3 hours to be among the first to drive through the new tunnel. They found it to be a magnificent feature of a magnificent highway. The Virginia Department of Transportation takes pride in this accomplishment and in the men and women who planned and built it, and in those who will operate it. Welcome to the Monitor-Merrimac Memorial Bridge Tunnel.